Okay, ladies and gentlemen, welcome to the video notes for Section 3, Chapter 2 in your geometry book. In Section 1 of Chapter 3, we introduced a bunch of new vocabulary words related to transversals of parallel lines. And now in this section, we're going to go through all of the rules that apply when that transversal is crossing a pair of parallel lines. Now, it's worth noting that all of these rules are based on a single postulate, the corresponding angle postulate. So this is something we will eventually use in proofs, the corresponding angle postulate. It says that if two parallel lines are cut by a transversal, then each pair of corresponding angles in that picture would be congruent. So, in this picture down here, we're told P is parallel to Q. So if P is parallel to Q, first of all, that would be seen in the form of a pair of darkened triangles indicating that P is parallel to Q. And this is a new symbol for some of us, these double parallel lines. That is the symbol for the word parallel. So that says P is parallel to Q. Okay? Now if P is parallel to Q and L is our transversal of lines P and Q, that forms those same 8 angles that we discussed in the previous section. We discussed in the previous section that that would create 4 sets of corresponding angles. So if P is parallel to Q, what that tells us is that angle 1 is congruent to angle 5, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. Because those are the 4 pairs of corresponding angles in this picture. 2 and 6 are both on the upper right at different points of intersection. 3 and 7 are on the lower left at different points of intersection. And 4 and 8 are on the lower right. Any one of those 4 sets of corresponding angles would have to be congruent based on this postulate because P is parallel to Q. Now, that means that if we have a set of parallel lines with a transversal, that would be the only rule we would need to add to our already existing rules of supplement theorem, which says that linear pairs add to 180, and vertical angle theorem, which says that vertical angles are congruent, in order to find all 8 of these angles if we were given just one of them. For instance, in the figure, the measure of angle 5 is 72 degrees. So angle 5 is a 72 degree angle. Find the measure of each of these angles, state which theorem or postulate you used. Well, if we look at number 1 is asking us to figure out the measure of angle 4. So if we look for angle 4 and angle 5 are corresponding angles. So since M is parallel to N, the corresponding angle postulate tells us that angle 4 is congruent to angle 5, which means that if the lines are parallel, if M is parallel to N, then that means that the measure of angle 4 is also 72 degrees, because the corresponding angle postulate says that since M is parallel to N, angle 4 must be congruent to angle 5, which means that the measure of angle 4 is equal to the measure of angle 5. So if we have a set of parallel lines, that would be enough for us to state that any pair of corresponding angles were the same angle, which means that we've now shown that angle 4 is also 72 degrees, and now we could use that angle in future problems if we needed to. So for angle 4 and angle 2, to find the measure of angle 2, well, angle 2 has relationships with both. Well, I guess the one we need to use so far, angle 2 and angle 4 have a relationship. Those are vertical angles. So by using the vertical angle theorem, we can say that angle 2 is also 72 degrees. Because the vertical angle theorem says that vertical angles are congruent. And in this picture, angle 2 and angle 4 are congruent, which means the measure of angle 2 is equal to the measure of angle 4. And we just said angle 4 was 72 degrees, so angle 2 must be 72 degrees as well. And we can continue this process. In fact, we will. What I'd like you to do is continue to think of what rule you would use in each case, and pause the video and try to find the measure of angle 6 and the measure of angle 1 on your own. They do use the same rule, in my opinion. So pause the video, give it a shot. Okay, so angle 6, it's very easy for us to look at angle 6 and say that angle 6 should be 180 minus 72, or 108 degrees. The reason for that is that the supplement theorem says that since angle 5 and angle 6 form a linear pair, the measure of angle 5 plus the measure of angle 6 is 180 degrees. So since angle 5 is 72 degrees, the measure of angle 6 would be 180 minus 72 degrees, or 108 degrees. Okay, and then finally the measure of angle 1, same argument. The supplement theorem says that angle 1 and angle 2 form a linear pair, which means that the measure of angle 1 plus the measure of angle 2 is 180 degrees, which means that the measure of angle 1 is 180 minus 72 degrees, or 108 degrees. And that's sort of how we approach these problems, okay? No matter what we need to do here, we have two pre-existing rules, the vertical angle theorem, which says that vertical angles are congruent, and the supplement theorem, which says that linear pairs are supplementary, they add to 180. And now we've added to that the corresponding angle postulate, which says that if these two lines, M and N, are parallel, then each set of corresponding angles is congruent. And using that, we only need one of these 8 angles in order to find the other 7 angle measures. Okay, so I think that's the end of the first video. The next video is going to discuss the various theorems that are based on the corresponding angle postulate. And then the final video of the section will show a few examples of how to apply those theorems. Thank you for your time.